Welcome to today's Statistics and Probability lecture on dependent events. This is probability without replacement. When you have a dependent event, you are not going to replace whatever it is that you took out. So when you do a trial, you're going to have an outcome. And then whatever that outcome is, you're not going to put it back. You're not going to replace it or reset your data. You're going to start from wherever you ended and then do your next trial. These are called dependent events because whatever happened in the first trial is going to affect the outcome of your next trial or your next experiment. So let's look at an example. If I have in a bag 1 green, 2 red, and 3 blue marbles, what is the probability of drawing 2 different blue marbles? What is the probability of drawing a green, then a red marble without replacement? What is the probability of drawing a green, a red, and then a blue without replacement? So to begin with, we've got 6 marbles in our bag, which means we have 6 possible outcomes. Then doing the probability for each event, we have the probability of green is going to be 1 over 6 because I have 1 green and 6 marbles of red. I've got 2 red marbles out of the 6 marbles. And blue, I have 3 possible outcomes out of the 6 possible marbles. So these are going to be my probabilities for my first draw. If I'm going to draw a blue marble, then my first probability is going to be 3 out of 6, which equals 1/2. Now for my second draw, I'm going to keep that blue that I drew, I'm going to keep that out of the bag. So now I just have 5 possible outcomes. I have 1 green, 2 red, and 2 blue. So that is going to change the denominator of all of these probabilities. All of those probabilities are now going to decrease by 1 and have 5 possible outcomes instead of 6. You'll also notice with the blue is going to also reduce by 2. It's going to be reduced by 1 to the number 2 because we took a blue out. So when you're doing your second trial without replacement, your total number of possible outcomes is going to reduce by 1, and whatever color or whatever event you took out, that one is also going to reduce by 1. So now to calculate the probability of drawing 2 different blue marbles, we have the probability of the first draw where I had 6 outcomes and 3 blue marbles. That gave me a probability of 1/2 or 0.5, which is 50%. And then the second time I draw, I'm going to have 2 marbles out of 5 possible marbles, which is going to give me 0.4 or 40%. Now to calculate the probability of drawing 2 different blue marbles, I'm going to multiply those 2 probabilities together, and that's going to give me a probability of 1 out of 5, which is 0.2, which equals 20%. I have a 20% probability of drawing 2 different blue marbles if I started with a bag of 6 marbles and 3 blue. Then I have a 20% probability of drawing 2 different blue marbles without replacing. Let's look at our next question. This one says, what is the probability of drawing a green, then a red marble without replacement? So once again, we have our 6 outcomes. Probability of green is going to be 1 out of 6, red is going to be 2 out of 6, and blue is going to be 3 out of 6. So if I'm going to choose a green first, then I'm going to start with the probability of 1 out of 6. I have 1 green out of my 6 marbles. Now if I'm going to choose a second one without replacement, I'm going to keep that green marble out. That's going to leave me with 5 marbles or 5 possible outcomes. That's going to change the probability of green. I don't have any more green marbles, so that means I have a probability of drawing green. It has a 0 probability. Red has a 2 out of 5. Blue has a 3 out of 5. Notice how the denominator of all of those probabilities decreased by 1, and the green possible outcomes also decreased by 1 because the green is what I took out. So now to get the probability of drawing a red marble after I have already drawn a green marble, I have 5 possible marbles to choose from. There's 2 possible reds, so that means my probability for drawing a red is going to be 2 out of 5, which equals 0.4. So now to calculate that probability of drawing a green and then a red, I'm going to multiply those 2 ratios together, 1 times 6 times 2 times 5. That's going to give me a probability of 1 out of 15, which is a 6.67% that I will be able to draw a green and then a red marble without replacement. Now let's take it to the next step. What if I wanted to draw 3 marbles? This time I'm going to draw a green, a red, and then a blue without replacement. You'll notice that these are my 3 trials, my 3 experiments. The first time I have 6 possible outcomes because I have 6 marbles. The second time I have 5 possible outcomes because I have 5 marbles. I took out the green and I'm going to leave that green out. The second time I'm going to leave the green and the red out. That's going to leave me with 4 marbles or 4 possible outcomes. Whatever marble color I took out, that one is going to decrease with the number of possibilities. So on my second try, I'm going to have 1 less green, and all 3 of them are going to have 1 less total possibility. On my third try, I'm going to have 1 less green and 1 less red, and all of them are going to be short 2 marbles. So they're all going to have 4 outcomes instead of the original 6. So now when I look at the probability for drawing each of these marbles, on my first draw I've got 6 marbles, 1 of them are green, so I'm going to have a probability of 1 out of 6 is going to be my probability of drawing a green marble. On my second draw I now have 5 marbles because I'm going to leave that green out. That's going to give me a probability of 2 out of 5 to draw a red. And then on my last one, I'm going to have 4 marbles in my bag. 3 of them are blue. So that's going to give me a 3 out of 4 probability for drawing a blue marble. To get that probability, I'm going to multiply each of those ratios by each other. That's going to give me a probability of 1 out of 20, which is a 5% probability that I will be able to draw 1 of each of those colors without replacing the marbles. Now you'll notice that if I had changed the order, my numbers, my percentages are going to stay the same, but you'll notice each time I multiply those ratios, that bottom number or the number of possible outcomes, that's going to change. So once again, for when I'm calculating the probability of an event, the top number is the possible outcomes for that color or that event, and the bottom number is the total number of possibilities in total. And then each time, if I'm doing it without replacement, each time that bottom number or the total number of possibilities is going to decrease by 1. And if I already drew that color out, that top number is also going to decrease by 1. I hope you have found this tutorial helpful. See the links below for additional supports and resources, and be sure to like and subscribe to get the latest videos by Caz Academy. I'll see you at the next video. Thanks for watching.